Death is truly a tragedy, but can it be used for a social cause? This is the cbse 2023 project. I am s.rishi of class 11F3 psbbk nagar. This project is performed by myself of psbbk nagar and sarvajit murali of class 11E1 psbbk nagar. Now, when I was talking about death, I specifically meant crematoriums. Electric crematoriums have become the new thing these days. They are much more cost effective, they are efficient, and can be used widely. But now, when we talk about pollutionless crematoriums, they still haven't made a mark there. What I'm saying is that in India, most electric crematoriums have absolutely no air filters to prevent the dangerous oxides of nitrogen, sulfur, and carbon coming from a burning body. At much, they might have a Venturi scrubber, which just clears out the particulate matter, but does not do anything about the gases that are being produced from the burning body. Our project aims to look at a cost-effective and pollution-less way of solving this problem. Let's take a closer look. Now, this is the fuming chamber where the body is burnt. When a human body is burnt, it causes oxides of nitrogen, sulfur, and carbon, some like carbon monoxide, carbon dioxide, nitrogen dioxide, to come out of the burning body. This might often be an incomplete combustion because an entire body is being burnt. When these gases travel up, we pass them into a sparking chamber. This sparking chamber is filled with a spark plug which is powered by the fuel inlet of LPG and has sufficient air. Why is this sparking chamber necessary? One of the gases that I mentioned before, carbon monoxide, is a very deadly and poisonous gas. It's not a regular greenhouse gas and cannot be dealt by on its own. So what happens is in the sparking chamber, combustion takes place and all these compounds are converted into their final oxide states. Carbon monoxide gets converted into carbon dioxide, which can then be dealt with sufficiently and easily. Valves are often present in our project to control when and where the gas is supposed to flow. Now, after spending their time in the sparking chamber, valve 1 opens and the gases flow up. The reason the gases flow up are because they are under tremendous heat and pressure. Once these gases flow up, they are passed through our cooling system. The reason for our cooling system will be mentioned here, but however, for now, our gases are under tremendous heat and hence they need to be cooled down to a temperature of 25 degrees Celsius to 31 degrees Celsius, which is helped and done by our coolant. These gases then pass through valve 2, which then opens, and these gases are at room temperature. They are then helped by fan 1 to come down and flow into the chlorella solution. This is now the most important part of our project. As you might or might not know, chlorella is a microalgae which takes in oxides of carbon, nitrogen, and various other gases and converts them into oxygen, thereby growing and reproducing in the process. This is known as photovolatilization. We make use of this advantage in our project. Once these gases pass into the chlorella solution, the chlorella simply absorb these gases and reproduce and grow under sufficient sunlight, aeration, and the specific 25 degree to 31 degree Celsius temperature, which is why we have a coolant here. Once these chlorella have taken in the gases, they begin to grow and reproduce, thereby giving off O2 gas. The O2 gas is slowly evolved up and through fan 2 and valve 3 is passed into the final exhaust where it is let off into the atmosphere. Not only are we breaking the chain where poisonous gases are let into atmosphere, but we are also releasing oxygen into the atmosphere, which will be a huge gain. Now, about the chlorella again, the chlorella is a microalgae, which means it's a living thing. So it lives, it dies. What happens to the chlorella once it dies? When the chlorella dies, it becomes organic matter which can be used as excellent fertilizer. The crematoriums could sell that chlorella matter and generate a second revenue of income. This project not only promotes a social cause of giving off O2 gases into the air and stopping greenhouse gases in their path, but also provides a way for crematoriums to earn more and farmer to get cheaply made manure. Now this truly is a social cause and is for the betterment of the environment. Talking about the cost, when I said our project is cost effective, it takes about 20,000 to 40,000 rupees. Now this may sound relatively big, but if you look at recent case studies of Krompet, Hastinapur and Navi Mumbai, 1 crore is being used to correct the crematoriums and their gas pollution for each of these crematoriums, and still none of our solutions are implemented. Compared to the hefty price of 1 crore, 20,000 to 40,000 could be easily cost effective. Talking about how much time chlorella would need to convert CO2 gas into O2 gas, not much exactly. Approximately about 1 to 3 hours would be required for this conversion. And depending on the size of this apparatus, 10 bodies can be burnt at once, and still not a speck of greenhouse gas comes out of this final exhaust. This truly is a social cost and is exceptionally good for the environment. And this is the chlorella project done by Sarvajit Murali of class 11E2 and S.Rishi of class 11F3 from PSBB KKN. Thank you.